Hello. So, in this today's video lecture, we will discuss what is arithmetical geometric progression. So, mixture of AP and GP. So, it is also called as AP-GP, arithmetical geometric progressions. So, what is exactly the meaning of this? Consider AP here. The heading is arithmetical geometric progression. So it is, we can say it's an APGP here. This is called as APGP. Consider AP, say A. The next term is A plus D, A plus 2D. Like this, the last term is A plus N minus 1D. And the common ratio we take as R. If you multiply with this with R raised to 0 R, say A into R raised to 0, A plus D into R raised to 1, A plus 2D into R raised to 2, and so last will be A plus N minus 1D into R raised to N minus 1. So this type of the sequence, this is a mixture of arithmetic progression as well as there is a common ratio also exists. So this type of sequence is called as APGP, or it is called as arithmetical geometric progression. So this type of sequence is called as arithmetical geometric progression. So how to find the sum of APGP? That's the basic question asked. The question is how to find the sum of arithmetical geometric progression. So here, this type of sequence, example of this, example say 1, 3, 5, 7, these are our normal arithmetic progression, and say as a 2 as a common ratio, so 2 raised to 0, 2 raised to 1, 2 raised to 2, so like this. So we can say 1 as it is 1 to 1 plus 3 into 2 plus 5 into 2 square, 7 into 2 cube. So this is called as APGP, arithmetic geometric series. The summation, the APGP summation. That is 1, 3, 5, 7 is in AP. At the multiple the term which is always, this is in the common ratio there. This 2 is a common ratio. So this step to identify the APGP is very important. Once you identify, there is very much standard method to find the summation of n terms of APGP. So now we move to the next part, that is how to find the sum of n terms of APGP. So here, how to find sum of n terms of arithmetical geometric progression. So in this case, suppose how to find sum of n terms of APGP. Consider APGP with having the n number of terms as A, next A plus D into R, A plus 2D into R square, like this, A plus N minus 1D into R raised to N minus 1, like this. So this is your APGP with the n number of terms. So it is say as here, the sum. So first step is you have to multiply with the common ratio. The step number with multiply with common ratio. So what is the common ratio? That is R. So throughout you have to multiply with common ratio R into S. That means in this term you have to write here, that is AR. You start writing in this one. Next will be what? A plus D R square. So like this. What is this? The next here is previous term of this is a plus n minus 2d into r raised to n minus 1, and one more term will come. That is a plus n minus 1d into r raised to n, like this. So one more term. Now we have to subtract. 2, 1 minus 2. This 1 minus 2 will give you s minus rs, that is 1 minus r into s. Here the first term as it is, which remain a only. If you take in this and this, if r common, then a plus d minus a, so that become dr. So there is dr. The next term will be dr square. If you observe this, a plus 2d into this, you say dr square. So like this, there the last term will be dr n minus 1. If we subtracting this and this, we give a cancel. This is d r raised to n minus 1. But one more term will remain there. That is minus of a plus n minus 1d into r raised to n, like this. So, and this is nothing but, here we have to use GB formula for this. This is geometric progression. GB with n minus 1 term. So we have to use geometric progression formula and then divide by 1 minus r throughout, and that's the final answer for this. So that's very, very easy. We can say this a and this will get cancelled out. This is like this bracket and this bracket together, and then divide by 1 minus r, and then simplify this. After that, simplify this. This is the method to find n number of terms. The sum of n number of terms in APG. This is find the sum of n number of terms of APG. Now similarly, we will find sum of infinite terms in this. Infinite terms. So here, how to find sum of infinite terms of ABGB. So remember that. So when it's come to the infinite terms is only possible. Infinite terms, sum of infinite term exists only if mod of r is less than 1. Because if mod of r is not less than 1, then sum of infinity will be infinity. So that is a very important concept. So in this case, suppose x is there, a plus d into r, a plus 2d into r square, like this, a plus n minus 1d into r raised to n minus 1. We will go with the same procedure, multiply with r. Here also the same. That is, here it is a plus dr square. But we just ignore this the last term. With the infinite series, there is no need to write the last term. Just subtract 1 minus rs is equal to a plus, that is dr square, dr cube, like this up to infinity. So here we will use infinity formula for we will use. So answer will be what? 1 minus r into s, a plus, use the formula s infinity of gp. Use the formula of s infinity of gp, which is nothing but first term divided by 1 minus common ratio, that is a plus whatever the first term, 1 minus common ratio. So using this and then divide by 1 minus r, then find s. Finally you have to find s. So this is the method which you have to implement when there is a sum of infinite GPs or infinite terms of arithmetic geometric progression. When there is an infinite number of terms, we have to use this particular method. So remember that when the n term, both the methods are same, only the infinite series method is quite easy because you don't want to write the last term here. You just take this and directly we can approach and find the answer. That's it. Okay, so we will solve a few textbook questions and then few MCQs based on this. I think everybody should understand what is the meaning of arithmetical geometric progression. It's a mixture of AP as well as it's a common ratio exists. So we can say it's called as a APG. That is arithmetical geometric progression. General question is find the sum. That's it. So we'll continue with questions. Yes, so exercise 2.5 the textbook. The sum is this. Question first, 2 plus 4x plus 6x squared plus 8x cubed up to n terms. So you can observe this properly. What we can say, 2, 4, 6, 8. This is in 8. If you observe this, the x is to 0 here, x is to 1, x is to 2. So this is in GP. So this becomes APG. What is this? It is a arithmetic geometric progression mixture. So what is Tn? First of all, you have to find Tn in this case. You have to find Tn. So Tn of AP is, what is the Tn of AP here? It is a plus n minus 1 into t. So a is 2 plus n minus 1 into 2. So 2 plus 2n minus 2. So it is 2n. Tn of GP. Tn of GP is access to 0 straight away, the first term. Because a r raised to n minus 1. It is a r n minus 1. So a is the first term, it is access to 0. R is x sub is x. So it is x plus to n minus 1. Therefore, Tn of APGP is equals to what? What is Tn of APGP here? It is 2n x is to n minus 1. So that is a Tn of APGP is there. Therefore, we can write s is equal to 2 plus 4x plus 6x squared plus 2n x is to n minus 1 like this. And then you have to form the method. The method is you have to multiply s with the common ratio. So we multiply the common ratio, that is x. So multiply by x. So x into s. We will not write the first term, we will write here, that is 2x. Next it is 4x squared. And so on. So here, one before the term will be 2n minus 2, x is to n minus 1. The next term will be 2n, x is to n, like this. It is 2n, x is to n. And then subtracting this two. The subtracting, this is number 1. This is number 2. So, as per rule, let's just follow the rule. That is 1 minus 2. So, it is 1 minus x into x. So that is 2 plus 2x, 2x squared, 2x cubed, and so on up to 2x plus 2 n minus 1. And the last is minus 2n x is to n, like this. That is the thing. Now this and this we can take together. So it is 2 minus 2n x is to n, like this. This is one bracket. And what about this? It is G, geometric progression with n minus 1 term. This is the n minus 1 term with the x as a common ratio. So therefore it is plus a, that is 2x, a into 1 minus r raised to n. Yeah. So 1 minus x raised to n minus 1 upon 1 minus x. Because there is an n minus 1 term. So a is first term. So first term is 2x. X is a common ratio. And n minus 1 terms are there in this. So finally, look at that. So what is the answer for this is, if it s is equals to, x is equals to, because it's 2 common if required, because 2 is taken common, it is 1 minus nxn upon 1 minus x. And here it is 2x, 1 minus x is to n minus 1 upon 1 minus x squared. So like this. So that is the sum of n terms in this ABGB. That is the answer for this. It's very easy because we divided 1 minus x here. So that is the answer. I think everybody understood this one. Right? Okay. Yes, point 5, the next question, question number 3. So 1 as it is, the next is 2 into 2, 3 into 4, 4 into 8, 5 into 16. The question is find the sum of n terms. Now, clear that here. First, if you observe the first term, 1, 2, 3, 4. So that is 1, 2, 3, 4, 5 in arithmetic progression. The next number is say 2 raised to 0, 2 raised to 1, 2 square, 2 cube. That is 2 raised to 0, 2 raised to 1, 2 square, 2 cube in geometric progression. So it is the given APGB is given sequences APGB form, that is arithmetic, or is arithmetical geometric progression. This is ABGD, and that is nothing but 1 into 2 raised to 0 plus 2 into 2 raised to 1 plus 3 into 2 square plus 4 into 2 cube and so on, like this. So it is like this. So what is the Tn for this? We find Tn of AP. So Tn of AP here is very simple. It is n only because it's 1 plus 2 plus is simply n. And Tn of GP is, what is GP is 1 less. 2 raised to 1, first term is 0. So n term will be 2 raised to n minus 1. So Tn of APGP will be what? N into 2 raised to n minus 1. Therefore, the sum of the required APGP will be S is equal to 1 into 2 raised to 0, 2 into 2 raised to 1, 3 into 2 square plus nth term, that is n into 2 raised to n minus 1. Now, we just follow the method. The method is you have to multiply with the common ratio. So, what is the common ratio here? The common ratio is 2. So, multiply by 2. So, it is 2s. I will not write here, I will write here. So, it is simply 2. It is 2. The next will be 2 into 2 square. Like that. Here it will be 1 less, which is n minus 1, 2 raised to n minus 1, n 2 raised to n, like this. So it is approaches like this. Then subtracting this. Then subtracting, that is 1 minus 2. This is say 1, this is say equation 2. So 1 minus 2, s minus 2s will give you simply minus s. So first term is as it is, which is 1. The next term is 2, this is 4 minus this, so that is 2. It is 2 raised to 1. This is p minus 2. is 1 is 2 square, 2 cube, that is up to 2 raised to n minus 1. And this minus n 2 raised to n. So it's like this. Now, these are nothing but, so this and this we get together. So there is a 1 minus n 2 raised to n, and this is the sum of n minus 1 terms of geometric progression, where the first term is 2 and the common ratio also 2. So it is 2 into 2 r raised to n minus 1 upon like this. Sorry, it should be n minus 1. 2 raised to n minus 1. So the final answer will be what? Is 1 minus n into 2 raised to n. This is 2 minus 1 is this. 2 multiply in, that will give you 2 raised to n minus 2. So that is a minus s. So it is 1 minus 2 will give you the minus 1. So it is n into 2 raised to n plus 2 raised to n, and this is minus 1. So final s will be n into 2 raised to n minus 2 raised to n plus 1. So 2 raised to n you cannot take common. That's the final answer for this. So s is equal to n into 2 raised to n minus 2 raised to n plus 1. n into 2 raised to n minus 2 raised to n plus 1. Yes, so next question of the infinite series is so 1, 2 by 4, 3 by 16, 4 upon 64. I already told you that the sum of the infinite series exists if the ratio should be less than 1. The common ratio, that is ABGP, the common ratio of the ABGP should be less than 1, because if it is greater than 1, it is automatically the nth term is already infinity. The sum is infinity. So it should be reduced. When this reduction is possible, when the r is less than 1. So here, if you observe it in this particular question, 1, 2, 3, 1, 2, 3, 4, like this, it is in AP. It is in AP, and this, the first term, say 4 raised to 0, because 1 upon 4 raised to 0, so that's not a problem. The second term is 1 upon 4 raised to 1, the next term is 1 upon this, 1 upon 4 cube, and so on. So common ratio is, here is, common ratio is 1 upon 4, so which is less than 1, therefore sum of infinite series is possible. So sum of infinite series in this is equals to 1 plus 2 by 4 plus 3 by 16 plus 4 by 64, like this, to infinity. So when its infinity is there, the method is saying that is s infinity we multiply with the common ratio, that is, you will not write here, so it is 1 upon 4, then it's 2 upon 16, then it is 3 upon 64, like this. And then this is number 1, this is number 2. So 1 minus 2, that is 1 minus 1 by 4, 1 minus 1 upon 4 into s infinity. Here the 1 is as it is, plus 2 minus 1, which is a 1 by 4. The next is 1 upon 16. Next is 1 upon 64, and this is infinite series. So this is you have to use sum of infinity for geometric progression. The sum of infinity for the geometric progression is a upon 1 minus this. That is the formula. S infinity is a upon 1 minus r. We use this formula here. So therefore 1 by 4 that gives you, and this is what? 4 minus 1, so it is 3 upon 4 into s infinity, like this. So here it is 1 plus 1 by 4, 3 by 4. 4 cancel, so this is 1 upon 3. 1 plus 1 upon 3. So that is 3 plus 1, that becomes 4 upon 3. That is 3 plus 1 is 4 upon 3. And this is 3 upon 4. So that becomes 16 upon 9. So here, therefore, S infinity will be what? 4 upon 3 into 4 upon 3, which is 16 upon 9. 16 upon 9. That is the answer of this. So answer for S infinity here will be what? 16 upon 9. Yes, one more question, that is question number 2, cut third. Here the question is 1 minus 4 by 3, 7 by 9 minus 10 upon 27. What is the sum of infinite series here? If you observe this, there is alternate plus minus is there. So whenever there is an alternate plus minus in GP, you have to give the plus minus sign to GP, not AP. So here, if you observe that 1, 4, 7, 10 in AP. So that don't give plus minus sign to the AP, because AP there should be the common difference. So it's always either the same sign, positive or smaller than. So here, this is there. But if you observe this term, so it is, we can say 1 upon 3 raised to 0. The next term is minus 1 upon 3 raised to 1. The next term is 1 upon 3 square. Then minus 1 upon 3 cube. And so on in geometric progression. The common ratio has minus 1 upon 3. So here the common ratio is minus 1 upon 3, and therefore the sum of infinite series in this, that is 1 minus 4 by 3 plus 7 upon 9 minus 10 upon 27, like this. You have to apply the same method, you have to multiply with the common ratio. So common ratio here is minus 1 upon 3 S infinity. So we'll write this here, minus 1 upon 3, this becomes plus, so 4 upon 9, then this becomes minus 7 upon 27, and so on, like this. So this is number 1 and this is number 2, and then 1 minus 2. So 1 minus 2 will give you 1 plus 1 upon 3 as infinity. 1 is as is. Here minus 4 plus 1 by 3. So minus 4 by 3 plus 1 by 3 is minus 3 by 3. So it is minus 3 upon 3. The next is 7 minus 4, which is 3 upon 9. So there is 3 upon 9. Then minus 3 upon 27. So it is like this. So if you take this 3 as common here, 1 minus 3 as a common, or 1 minus 3 as a common. So this becomes 1 upon 3, then minus 1 upon 9 plus 1 upon 27 minus like this. So that is there. So we take minus 3 common. So this is nothing but 1 minus 3. This is the sum of, again, infinite with 1 upon 3 as a common ratio. Minus 1 upon 3 is a common ratio. The method is same. So it is A upon, so A is 1 upon 3. 1 minus 1 upon 3 as a common ratio here. And this is 3 plus 1, that is 4 upon 3 S. So it is 4 upon 3 into S. So this is 4 by 3 S is equal to 1 minus 3 1 upon 3, that is 3 plus 1, so it is 4 upon 3. 3 cancel, so that is 3 by 4. So finally it will be 4 upon 3s is equals to 1 minus 3 cancel, so it is 3 by 4. 4 minus 3, that is 1 upon 4. So 1 upon 4, 4 upon 3s, so therefore x is equal to 1 upon 4, 3 by 4, so it is 3 by 16. So that is sum of infinite terms. His answer is 3 upon 16 for this particular question.